The midpoint of a segment is the point that divides the segment into two congruent segments. So the midpoint, if I'm looking at a picture, I have, I don't know, we'll just have this segment AB, and we'll put M in the middle. That'll be our midpoint. Now, the way it's drawn on the pictures, you'll see these little tick marks here. This tells you that M is the midpoint of segment AB. Okay. Now, what this also means here then is going to be that segment AM is congruent to segment MB. And then, kind of what we talked about the other day as far as congruent segments, that means that the distance from A to M is equal to the distance from M to B. Next we have a segment bisector, and a segment bisector is a point, ray, line, line segment, or plane that intersects the segment at its midpoint. So basically, if we go back to our drawing of this segment AB, and then M is the midpoint, there's something that cuts through this segment through M. So it could be anything, it could be any of our things. Let's just draw a line here. I don't know, we'll label it CD, say. Okay, so we would say that line CD bisects segment AB. At point M. Okay, so I could give you this drawing, or I could give you this statement, and they mean the same thing. You have to be able to kind of go from one to the other. I give you the same statement, you need to be able to draw this drawing. I give you the drawing, you need to interpret that to mean this. That I have a line cutting through a segment. It could be a point ray, could be anything. If line CD bisects segment AB at M, that means that M is the midpoint, or the midpoint. Of segment AB. Okay. That tells you then that AM is congruent to segment MB, which means, again, like we did before, that means AM, segment AM, or the distance from A to M, is equal to the distance from M to B. And then, so this line CD is a segment bisector. Our first example says that segment VW bisects segment XY at T, at point T, and the distance from X to T is 39.9 centimeters. They want us to find the length or the distance from X to Y. So this right here, this statement, VW bisects XY, that tells me that I have some segment XY, and then I have this segment VW that cuts through this segment. It intersects it at point T. Now the word bisect tells me that it cuts it right in half. So T is going to be my midpoint. And then so my segment here, my segment VW, okay, looks something like that. And then since it bisects, remember that means these two pieces are congruent. And so the length of XT is 39.9 centimeters. So that means because T is the midpoint, that tells me that this side is also 39.9 centimeters. Okay. So to find XY, I would need to add XT plus TY. Right. Both of them happen to be 39.9 centimeters. Okay, so then I would just have to add those two together. That tells me that XY is going to be 79.8 centimeters. Next example, point M is the midpoint of segment VW, and we want the length from V to M. This example, you notice that the drawing is already done for you. However, now we have some algebraic expressions, but it's still the same setup. M is the midpoint. That means these two pieces are equal. So you know that the length from V to M is equal to the length from M to W. Okay, so all we have to do then is substitute in these algebraic expressions. So I'd say 4x minus 1 is equal to 3x plus 3. And to solve this, I would add 1 on both sides to cancel this out or zero it out. Then I'd bring down my 4x on the left. I'd have 3x plus 4 here. Then I would have to subtract. I remember that we want to get our constants on one side and then our variables on the opposite side. So I have this x right here that I have to get rid of. I have to move to the other side. So I want to zero that out. 4x minus 3x is x. And then bring the 4 down, so that tells me that x is 4. Okay, we're not done because we want the length from V to M. So that means I have to substitute. I have to plug this in. So V to M is 4x minus 1. So I'm going to substitute 4 in here for the x. I'm going to replace it. So 4 times 4 minus 1. That gives me 16 minus 1, which is just 15. So the length of VM is 15 units. Okay, and number 3, or example 3, says the endpoints of segment AB are at 2 and 8. Define the coordinate of the point P that partitions the segment in the 2-to-1 ratio. Okay, so for this one, let's draw a segment here. Really, we're drawing a number line, but so I have a point here, A is at 2. And B is at 8. All right, so what they want us to split this up into 2-to-1 ratio, meaning this piece from here to here has to be twice as big as this piece right here. Okay. So what we need to do to find this out, P is somewhere right here. We want to figure out what that value actually is. So the length from here to here, that whole distance is 6 units. Okay. Now this 2-to-1 ratio, really what that's saying is I'm breaking this up into 3 pieces. So this part right here would represent the 2 parts versus the 1 part. So what I have to do with this 6, this length of 6, I'm going to take the 6 and I want to divide it by 3, which gives me 2. That tells me that this right here is a length of 2. This is a length of 2. And this is a length of 2 units. Okay. So this part right here would be twice as long as this piece over here. So that tells me that here, this has a length of 4 units, or this would have a length of 2 units. Okay, so I'm going to kind of write this out. This would be 2 units per part. So to find P, I need to go 4 units to the right. So P is going to be, we're at 2 plus the 4, which tells me it is going to be at 6. That's the coordinate. Next problem says the endpoints of segment CD are -3 and 5, and we want to find the coordinate of the midpoint M, CD. So I have my number line here, and let's say that I put C is here, which is -3, and D is over here, that's 5. Okay, what I want to do to find the midpoint is I'm going to take the -3 and I want to add the 5, and then I'm going to divide that by 2. Okay, so I'm taking this length and I'm cutting it in half. All right, so -3 plus 5 is 2, divided by 2 is 1. So the midpoint for M my m right here is going to be at 1. All right, now we're looking at the midpoint formula, and that's when we have a segment on the coordinate plane and we want to cut it in half, we want to find the midpoint. So if we have some point A, we put it at x1, y1, some point B, we put it at x2, y2, then the midpoint of the segment AB is basically, if you want to think of it as the average of the x values and the average of the y values. I take x1 plus x2, divide by 2, and I take my y1 plus y2 and divide by 2. That gives me my x and y coordinate for the midpoint. And we'll look at an example. Example 5a says the endpoints of segment RS are at R is 1, -3, and S is at 4, 2. We want to find the coordinates of the midpoint. So to do this, we pick our points, and I'll let x1 or R be the x1, y1, and I'll let S be the x2, y2. Okay. So to find this, what I have to do is I take my x values and I want to add them. So I'm going to have 1 plus 4 divided by 2. That gives me, it's going to give me my x value. The y value, I'm going to have to take -3 plus 2, divide that by 2. That's going to give me m. Okay, so 1 plus 4 is 5. That's going to give me 5 halves. -3 plus 2 is going to give me a -1. Divided by 2 give me a -1 half. So this is the coordinates of my midpoint. For example 5b, what we have to do now is they give us the midpoint. We have to find one of the missing endpoints. They gave us the midpoint is at 2, 1. One of the endpoints, in this case they gave us j, is at 1, 4. They want us to find the other endpoint k. All right, so let's graph this to kind of see where we're at. I'm going to graph m at 2, 1. So that's 2, 1 here. That's going to be m. J is at 1, 4. So 1, then I have to go up here. That's j. All right, so the question becomes, how do I go from here to here? Well, from here to get to, k is going to be down here because m is in the middle. So to figure this out, I'm going to go 1 unit over, so 1 to the right. Then I'm going to come down, how many units? I'm going to go down 3, right? Okay. So since this distance from j to m has to equal the distance from m to k, I'm going to follow the same pattern. How did I get from j to m? Well, I went right 1, so I'm going to have to go right 1. So that's going to put me here at 3. So I know for k I'm going to be at 3. Then I have to go down 3 units. So I'm going to go down 1, 2, 3. That puts me right here. That should be k. Okay. So the amount that I move to the right to go from j to m, I have to move that same amount from the midpoint m towards k. So I go 1 right, and then I go down 3. Okay, so that gives me the coordinates of k, which is going to be -2. All right. If you want to look at it a different way without looking at the graph and just looking at the coordinates at the points, j is at 1, 4, m is somewhere in the middle, and k is down here. Okay. Tells you m was at 2, 1. So basically what you're doing, this distance has to be equal to this distance. So the question is, how do I go from 1 to 2? Well, I have to add 1. So that means I have to go that much to go from m to k. So I'm going to add 1 more. That gives me 3. Okay. Do the same thing with the y values. How do I go from 4 to 1? Well, I have to subtract 3. Okay, so that means from down here, I have to do the same thing. I'm going to subtract 3. So 1 minus 3 is going to give you a -2. Okay, so that gives you the coordinates, and if you notice, it's the same answer.